They need to review.
Because how many ways are there to solve math?
Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solve perimeter is?
2 times length plus 2 times width.
Good afternoon and welcome to Count on Us.
Your Telly Award-winning math homework hotline. I am Mrs. Davis here with my fabulous partner.
Mrs. Walters, it's good to be here. I'm so glad to be here with you.
It is so nice for all of you to join us this afternoon with answering any math homework questions that you might be having. You can always give us a call. The number here is 301-772-0080. And you can watch us on your Comcast and Verizon television channels. So you can tune in to...
We're on Comcast 96 and Verizon Channel 38, and you can also look at us on the web at www.pgcps.org, and you can click in on the television services department, and you should be able to see us live and in living color with just a little bit of a delay.
Yes, just a little bit of a delay. So you may tune in to get your math homework questions answered. Now, one of the things that we like to do is challenge each and every listener and viewer out there with our challenges. So if this is your first time joining us, we have something called 24 Challenge. And the reason that it's 24 Challenge is because you must get a total of 24. So take a look at our cards here. You can use any of the operations: adding, subtracting, multiplying, or dividing to get a total of 24.
Yes, and you have 4 cards to choose from.
So please take a few minutes to jot these down so that when you call in, you'll have a chance to see if you can challenge yourself to get 24. So card A, the 4 numbers that you will be using are 5, 8, 4, 7.
Card B, we have 8, 4, 7, 8.
And since you have 2 8s, you have to use both of them.
Yes.
Card C, 1, 2.
Now, how do you know which one that is, a 9 or
The
a 6?
shaded in one is a
9.
and the unshaded one is a 6.
Okay.
And card D.
Card D, we have 9. Again, that red center. 4, 8, and 4.
And again, remember, go ahead and jot these down because you are challenging yourself to get a total of 24 using adding, subtracting, multiplying, or dividing, or any combination of the operations.
Yes.
But you must use
All
all
four
four
numbers.
digits or numbers on the card so that you get a total of 24.
And, you know, if someone solves the problem the same way you did, think of another way because there's multiple ways of solving the same problem. Okay? This is going to get your brain really thinking about numbers, mental manipulation.
And mental math so that you
Yes.
will be fluent, because one of the things that we must have are fluent math students.
Yes, and you have to know your math facts
in order to be fluent.
Once you know your math facts, math will become easier. Try it. I promise you, if you study 10 minutes a day, as little as 10 minutes per day, you will improve so much and you will get so much faster in recalling your facts so that you can learn different concepts in your math class. And you don't have to be bogged down by saying, okay, how much was that? 6 times 8,
Okay.
By that time, you forget what the problem was to begin
Right.
with.
So just take a few minutes to learn those math facts. You're adding, subtracting, multiplying, and dividing. Dividing. That will help you out tremendously.
Yes, it will. Okay. Well, you know what? This week we have testing, don't we?
Oh, wow.
Unit 2 testing.
We're
going by so
my
fast.
goodness, so quickly. And the students have been learning a variety of things. And I just wanted to, since you were reminding them to practice their math facts, many of the students have an online access that they could use at elementary. And that's an excellent way to practice your math facts as well, taking advantage of those online resources that you have to practice.
And you have, what is it, First in Math.
First in Math.
Yes. First in Math. You can definitely get on that at school and at home.
Yes.
Okay.
In order to practice. So, what are some of the things that students are doing?
Well, I know our third graders were learning about multiplication.
Oh, really?
And the different vocabulary or I won't say keywords, but working on word problems and how to figure out whether they needed to multiply or perhaps add the numbers in order to come up with a solution to a problem. I don't want to say keywords. We don't want keywords because sometimes the same words can mean different things.
Yes.
Depending on the problem. Okay? They were learning about arrays. So that's vocabulary that's normally associated with multiplication. What else? They were learning about repeated addition.
Oh. So instead of when do you know, how about how do you know?
How do you know?
Okay, so we had repeated addition.
And even with the fourth graders the other day, we had 48 times 18.
Okay.
And
48
we tried adding it.
Times 18.
Adding 48 18 times.
You did?
And
did you have lots of time? Did you have lots of time on your hands?
Exactly. We wanted to figure out which way was more efficient, to do repeated addition or to multiply the numbers.
Okay, so I've decided I'm going to just add it 2 times. So will that give me the same thing as 48 times 18?
No.
Well, that's going to be quicker.
Well, actually, switch these numbers, 18 times 48, because that will mean we have 18 48s.
Oh.
Right. Some people say, oh, it doesn't matter. Yes, it does. It means different things.
Okay, so here we go.
Well, you were right. You were right. This is 18 groups of 48.
18 groups of 48. 18 groups of 48.
Correct.
Okay.
Which means I have to add 48 plus 48 plus 48 plus 48.
18 groups of 48.
18 times.
48 plus 48 plus 48.
Yes.
Plus 48 plus 48 plus
And
48.
I said, oh my goodness, by the time we finish writing this out, I could have come up with the product.
48 plus 48. Am I done yet?
No.
Keep going.
Keep going.
Plus 48 plus 48 plus 48.
You got 6 more to go.
Oh my goodness, plus 48. Well, can I just put tally marks and be done with it?
Tally marks you want to use? I think not.
Okay, am I done yet?
Let's see. No, you need 3 more groups.
Well, let me see. I know 3, 6, 9, 12, 15. Oh my goodness, plus 48, plus 48, plus 48.
Okay, now what I did, I told the students, all right, let's solve. Some of you solve it with the repeated addition, and the rest of us will do it through multiplication.
Okay. So
And-
which one should we
I think I'm going to let you do the repeated addition. How
You're
about
gonna
that?
let me do repeated addition? That is so nice of you. Repeated addition.
You do
Okay.
repeated addition on yours. Let's see. You
Okay.
do your half like that.
Okay, so we're going
right.
to split it in half.
And I'll do,
Okay. Well, let's see. 48, that's close to 50. Okay. So I know that 10 groups of 50. 10 groups of 50 would be, that would be 500. Okay.
still working?
Yes, I'm still working.
Oh, wait.
8 groups. I'm going to do 48 is close to, so if I have 8 groups of 50, that will be 400. 8 groups of 50.
Okay, even with my
50
error.
times 8. Oh my. That would be
I'll
400.
I'll even do
So
another
here
way.
we go.
Oh, see, you had to resort to that anyway.
48 is close to 50, so I have 10 plus 8 equals 18. So that's gonna give me so my answer, so 50 times 18, I think that's gonna be something close to 900. But I had 2 extra for each of my 8. 2 extra. So minus 36.
Oh my goodness. Oh my goodness. I have done it 2 ways.
Okay.
So this is what we mean by being efficient. See, you still resorted to multiplication. You didn't
Okay,
fully
so
just-
I'm thinking, I'm thinking my answer should be
864.
864.
And that will be correct.
Oh, well, what did you do?
I did it 2 ways. First, I did the traditional algorithm, but then I thought about place value. So I multiplied 48 times 10 and got 480 as my product. And then I did 48 times 8 with 384 as my product, and then I added them. Same like this, partial products, and we added to get a total product there.
Okay, well, let's see. What did I do? Well, I thought that 48 would be close to 50. So if I added, maybe I should have stuck with adding. If I add 50 plus 50, that equals 100. 50 plus 50, that equals another 100. So that's going to be 200. And then 50 plus 50 equals another 100. So I'm at 300. 50 plus 50 equals another 100. So I broke 18 up into 10 plus 8. So 1, 2, 3, 4. So this is my 8 50s. Well, let me go ahead and do my 10 50s plus. So 50 plus 50 equals 100. So this is my 10 groups
50s.
of 50. And so when I total that up, that gave me 500. But now I need 8 more
Right?
to have my 18. So 8 more groups of 50. 50 plus 50.
I would encompass these.
50 plus 50. 50 plus 50. So this is kind of like, you know, you need to know your 50s.
Yes, you do.
You
that
need
would be
to
like
know
a
your-
benchmark number.
Yeah, a benchmark number, so you can always think of this. So each one of these would equal to 100.
100.
So this would give me a total of 400. So let me put that there. Okay, so my 500 is in the way, so I'll have to write small. Okay, so now if I add right here, this 400 right here.
Mm-hmm.
And this 500 right here, that's where I got my 900.
Mm-hmm.
But for each one of these, I was 2 over.
Yes.
Because I only really had 48.
Mm-hmm.
Each one was 2 over.
Correct.
So I need to subtract 2 18 times.
So that would be 36.
Yes.
Okay.
So if I did 18 groups of 2.
Right.
Which
So
would
this
give
would
me
be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36.
Okay, so now I have 900 was my estimate, but that's too big.
Mm-hmm.
I got to back it off 36 times.
Yes.
And so now I can subtract, and I know, oops, this is equal to
864.
864.
There's so many different ways you can do it, but we were talking about being efficient.
Okay, so you beat me.
Oh, yes.
So if you beat me, does that mean you were more efficient?
It means I was efficient, but we were both correct in our solution.
Right. So it depends upon how much time you have. Mm-hmm. And, you know, if I thought about this in my brain as opposed to just writing it all down.
Right. See, and that's what learning and knowing your facts does for you. It allows you to manipulate the numbers in your head and think about numbers in many different ways and make connections and then, you know, put down what works best for you.
All right. Okay, so where's the array?
Oh, the array. Oh, my goodness. For this particular problem,
Maybe we better get another one.
let's get a smaller problem.
Okay. But it's still the same concept, though,
Yes,
right?
multiplication.
Okay, how do you spell array?
A-R-R-A-Y.
Array. So does that mean one ray?
No, when you think of an array, you think of rows and columns.
Oh,
if you will.
rows and more than one row? Rows and columns.
You could have one array of something. For instance, if you had 1 times 7, you would have one row of 7.
So which one comes first, the row or the column?
I normally count the rows. Well, actually,
Rows. Does that go across?
no.
Does it go like X and Y? Rows
yes,
and columns?
Yes. Yes.
Okay.
Okay, let's
Let's see.
connect it to middle school here.
Arrays. So if you're talking about an axis, you always go across on the x-axis first, and then you go on the y-axis. And so these would be rows going across, and these would be columns. So is that how it works?
Well, you know what? That's not normally how I think of it. If I have, let's just do something really simple.
Okay.
If we had this as an array, I would say I have 2 rows of 3. 2 rows with 3 in each row.
So this
I don't know.
is 2 rows. Oh, look. Rows are going across. 2 rows of 3.
Okay.
So now my columns are going down. So this is 1, 2, 2 rows. Columns, 1, 2, 3.
Okay, so normally I think of columns as being up and down.
They are up and down. 1,
Oh, I
2,
got you.
3.
Oh, okay. See, we're seeing it different ways, but I see.
Okay,
I got you.
so then that would mean the same thing as, how would I make that? Okay, so you called it an array, but I wanted to do multiplication.
Okay, so how would you do that with multiplication? You use an array for multiplication, yes?
Oh, an array can be used for multiplication?
Yes.
An array can show multiplication.
Because you have equal groups of objects in each row.
Okay, so what exactly do you mean?
All right. The closest thing I can think of is like a movie theater. Okay. If you had a movie theater and you had, let's say, we had.
So are we still going to use our 2 and 3?
We can.
Okay.
We have these rows of seats.
Okay.
Okay, and each row has 3 seats in it.
Uh-huh.
So I have 2 sets of 3, or 2 threes, or 2 times 3, which would give me 6.
Ah, so this is the same thing since I have 2 right here. 2 times 3. And when I count them all up together, it gives me a total of 6.
Correct.
Oh, so that's how that array thing works.
Also, the students have been working with equal groups of objects.
Oh, equal groups.
And have you ever heard of the game Circles and Stars?
No, let's play it.
Okay. So with Circle and Stars,
Okay.
what we normally do, if I can find a number cube here really quickly.
Oh, they probably ran away. Shall we use a spinner?
Yeah, let's use a spinner.
Okay, what did you call this?
Circles and Stars.
Circles and stars. I wonder if we have any new markers.
Oh, here's one. Well, actually, there's one right there.
Okay. Circles and stars.
Yes.
Okay, so circle. Okay, do we have to do like this?
Well, and actually, if I could find my number cube, let's say I rolled a 4. So the first number that I
Oh,
roll,
look, a calculator with a random number generator.
if the first number I roll is a 4, that tells me how many groups I'm going to have.
Okay, so, oh, wow.
Okay?
Yuck. Okay.
And then if I roll a 3,
Okay, so
that tells
4.
me the number of stars I'm going to put in each
3.
circle. Okay?
Is it time for a break yet?
So what I'm going to do is I'm going to put 3 stars in each of these circles.
Okay.
So I have 4 groups of 3.
Ah.
And that's how we write it. 4 groups of 3. Or we have 4, I'll write the name out, 3s. Or we have 4 times 3. And our product would be 12. Okay?
Ah. So that's how you do.
That's stars. That's
That's
correct.
how you do. Oh, well, I want to do one then. I want to do one.
Okay. All right.
Okay. Let's see. Okay. I'm going to use the calculator.
Okay. What number do you want?
Okay.
Should I
So
just
whichever one
make
I
it-
press on. Okay, that is.
Well, it's close. It's closest to 7. Okay, so 7
Okay.
circles.
Okay, so I'm going to have 7 circles. Okay. And, okay, here we go. Get my finger near the number. Okay, and I have 5 stars.
Yes.
Ooh, that's going to be a lot. That's going to be a lot. Okay. All right, so you said when I have circles and stars.
Draw 7 circles first.
7 circles. 1, 2, 3, 4, 5, 6, 7.
All right,
Okay.
and you have to put 5 stars in each circle.
I have to put 5 stars in each circle. Okay. 5 stars in each circle. 1. Look at my star is looking a mess. Let's see. 1, 2, 3, 4, 5. Okay. Okay, so that's 5. 1, 2, 3, 4, 5. Some cute stars I'm drawing here. 1, 2, All right. All right. 1, 2, 3, 4, 5.
Oh my goodness. You need help? 1, 2, 3, 4, 5. 1, 2, 3.
You know, it's so great to work together.
5.
Okay.
There you go.
All right. So, hey, I can count by 5.
You can. You
Okay.
certainly can. You can
So,
count.
5, 10, 15, 20, 25, 30, 35. So there are 35 stars.
Correct.
Okay, so I figured out how many stars, but I don't know what I'm supposed to write.
Okay, well, yes, 35. Now, what happens is after we take maybe 5 turns apiece.
No, but what was that other
okay.
thing you wrote? I don't
The
know how
other
to do
thing?
that other thing.
Okay, so
What was that other thing?
you had 7 groups. I'm just going to 7 groups of 5
Okay,
or 7
I'm going to write it here.
5s.
7 groups of 5. Okay,
Or you had, and underneath that we had 7 5s.
7. Oh, because there's 5 in it. 7 5s.
Or 7 times 5.
Oh,
That's how we get our
or 7
expression.
times 5.
And then you put your
Equals?
equal signs and make it an equation and get
35.
your product, 35. So if we were playing against each other,
Okay.
my product was 12, yours is 35. Then after maybe 5 goes, we would add up all of our products, and the sum, whoever gets the highest number is the winner.
Oh. Okay, so my score is 35 stars.
And mine was 12.
Oh, okay.
Okay.
All right.
But that was just
So
the first time.
35 is, if I give 2 dots to 35 because it's bigger than 12 and 1 dot to 12, and I connect the dots, 35 is greater than 12.
I love it. That is a great way
my
of doing that.
goodness.
You know why? Because students always seem to forget the symbol for greater than, less than, for inequalities.
So
I
this
like
is-
that.
And look, some people talk about an alligator mouth. So here are the teeth right here. This is the tongue. You have more teeth than you do tongues.
That's one way. So I like that. Let me try it. Let me try it.
Okay, you want to?
I want 12. I'm going to put the 12 first.
Okay, 12.
And 35.
All right.
So you put 1 dot here because that's the least of the 2 numbers. 2 dots here, and then connect the dots. I love it.
And in an alligator mouth, you have more teeth than tongues.
Oh, great.
I just thought of
love
that
it.
one.
I love it. I'm going to share that one with my teachers tomorrow.
Oh, wow. Wow. So if you happen to have any homework that you need some help with, can we ask them to join us on the other side of the break?
Sure.
All right. We'll be right here waiting for you. Please join us on the other side of the break.
Hello, my name is Jessica and I attend James Ryder Randall Elementary School. I am in the 5th grade. Today, the math problem is, during some months, Earth revolves around the sun in 30 days. How many seconds is this? Well, there's 24 hours in one day. So in order to find the hours in 30 days, I must multiply 30 times 24, which equals 720 hours. In order to find out how many minutes are in 720 hours, I have to multiply 720 times 60 because 60 minutes equal 1 hour. And that equals 43,200 minutes. Next, in order to find out how many seconds are in 43,200 minutes, I must multiply 43,200 times 60, because 60 seconds equal 1 minute. And that equals 2,592,000 seconds. So 30 days equal 2,592,000 seconds. Woo! That was a lot of seconds. I hope you found the solution to your problem easy to follow. This is Jessica from Counting Us. Bye. See you next time.
Hey you, yeah you, stay right there, I gotta tell you something. I bet you know someone with type 2 diabetes. Guaranteed, you know why? Because 1 out of every 3 little kids is gonna develop diabetes in their lifetime. That is can lead to heart problems, strokes, and even blindness. I'm John Sally, and I'm telling you, it ain't gotta be that way. Now you can up your defenses by eating more fruits and vegetables, having more vegetarian and vegan meals. These steps can be the power plays to protect you and your family against the risk of diabetes. Learn more, go to blockdiabetes.org.
He was so inspiring.
He took chances.
He was so moving.
He lived daringly.
Martin Luther King Jr. was a man of service, and his day shall be a day of service.
He inspired us in words, but he led us in deeds. To honor him, let's do the same. Go to mlkday.gov and find out how to volunteer on Martin Luther King Day and beyond. This message is brought to you by the Corporation for National and Community.
Okay, guys, ready? Here we go! Let's smile and brush our teeth twice a day, every day. Let's smile and floss our teeth once a day, every day. Let's keep that smile a happy place on your face with good nutrition and dental visits. Let's smile, let's smile, let's smile, let's smile!
Good afternoon and welcome back to your Telly Award-winning Math Homework Hotline. I'm Mrs. Davis here with my new Hocus Pocus fabulous partner,
Mr. G.
Hi, Mr. G.
In the place to be.
All right, in the place to be. You are right on time. If you have homework, just call the homework hotline. And the number is 301-772-0080. Yay!
Call us up.
So, we're here to help you with any math homework that you might be having.
There you go. Call us up
Whether
with
you're
your
in
problems.
elementary school through 6th grade, right?
All the way to 6.
All the way to 6th grade. That's what we're here for today. So, Mr. G, what have your students been working on?
Oh, I saw you working on some multiplication earlier.
Uh-huh.
And we're doing some of that. We're doing a little bit of fraction work.
Fractions?
Yes.
Oh, wow.
Yes.
Fractions.
Do we have any fraction tiles? Or
Yes,
should
we do. We
should
have
we talk about
fractions
our challenges before we go
Oh,
on
yeah,
to that?
we need to get our challenges. Put those back up, please, if you don't mind, Mr. G.
Yes.
All right, so if you
24.
if you are out there listening and you have not had a chance to jot down the challenges, the way that this works, can you explain it to them? I said it one time, but you might say it a little bit better.
Okay, I don't know about better, but
another way.
You have to take all 4 numbers, 1, 2, 3, 4, and use any math operation to make those numbers equal 24. I already have the answer to that one.
You do?
Just
I don't.
like that.
Okay, so the numbers for card A. So you tell us which card you want to work, right?
Exactly.
So this is card A. So the numbers you could use on card A are 5, 8, 4, and 7.
Card B is 8, 8, 7, 4. I have the answer for that one.
Woohoo! Ooh, Mr. G!
Yeah.
All right, card C, 1, 2, and when it's shaded in, it's a 9.
And card D,
6, and now D.
And card D is 9, 4, 8, 4.
And do you have the answer for that one?
Oh, no.
What about this one?
That one, let's see. Yes.
Oh, you have the answer for that?
Yes.
Mr. G, you're just great like that. Is that what G stands for? Great?
Woohoo!
Mr. G is so great with those challenges. Wow. And I'm wondering if we have a caller or maybe or almost. Okay. So, Mr. G, you were saying something about fractions. Look what I did when you guys weren't looking.
Oh.
My bicycle wheel got a flat tire.
You can make some fractions out of that, though.
I know, but we have some number tiles.
Let's see. Do we have some?
Yeah, right there. I just put them
Are
over
they?
there.
Oh!
Number tiles. So, in case you don't want to use a flat tire bicycle, okay, so we have
one hole.
You want to put them all out and then separate them so they can see what they look like? All right.
Hopefully your teachers are using these in the classroom.
Okay, and maybe you've seen them before. Okay, how do these work, Mr. G?
Well,
you stack them on top like a sandwich?
You could do that, and I wouldn't recommend eating them. But what you can do is,
okay,
this hole is broken up into different pieces. So,
okay.
But it looks like we have a caller.
So we will have to postpone our fraction demonstration because is this Felicia? Felicia?
Hello.
Hi, Felicia. How
Hey.
have you been?
Are you there?
Felicia, how have you been?
Good.
It is so nice of you to call us today. Now, Felicia, I have a question for you. What grade are you, Felicia? What grade are you?
What is 739 divided by 7?
Turn your TV down, Felicia.
Felicia, can I ask you to turn your television down? And then before you ask me a question, I want to ask you a question. Felicia, what grade are you?
5th.
6th grade?
6th grade, okay.
5th.
5th grade.
5th, okay.
And can you please give a shout out to your school? Felicia, can you give a shout out to your school?
She's doing math.
What school do you go to when you go to school, Felicia?
Cherokee Lane Elementary School.
There you go. Cherokee Lane.
Cherokee Lane. Wow. Now one more shout out. You get to shout out your teacher. Who's your teacher?
Miss Watson.
Miss Washington. Well, please tell
No,
Miss
Miss Watson.
Oh,
Miss
I'm
Watson.
sorry, Miss Watson. Please tell Miss Watson we said a great big hello from Count on Us. Now, Felicia, that we've taken care of all of those things, your name, your school, your teacher, your name is going into the treasure chest because we treasure all of our callers that count on us. You may now ask a question. Okay. Felicia, what is your question?
What is 39 divided by 7?
Okay, I'm sorry. Can you repeat that one more time? And Mr. G, who's so great, is going to help you with that. What is your question?
What is 739 divided by 7?
739 divided by 7. Is that correct? Is that correct?
Yes.
Okay, so how well do you know your 7 times tables?
Pretty well.
Pretty well? Okay, good. So let's take each number step by step. So that's 700s. Can we take 700s and break them up into 7 equal groups?
7 can go into 7 once.
So we can, and each group will get 1 of the hundreds. We take those away. We're left with 0. Now we have 3 tens. Can we share 3 tens with 7 groups? Felicia?
Huh?
Can we share 3 tens with 7 groups?
No.
No, we can't. So what happens is that 3 tens gets grouped with those 9 ones. Now we can change these 10s to 1s and we have 39 ones. Can we share 39 ones with 7 groups?
Yes.
Yes, so we have 39. If we share them out into 7 groups, how many will each group get?
5.
5. And if we give each group 5, how many will we share out altogether?
Huh?
if we share out 5 to each group, how many will we have altogether?
How
many of those 39 will get shared out?
4. 4.
Not 4. 35 of them. 4 will be left over that can't be shared. Now, did your teacher tell you to use a remainder or you're using decimal numbers?
The remainder.
Remainder? So how many remain that can't be shared?
4.
4. So your answer is 105, remainder 4. 4 of them that cannot be shared with the group of 7. Do you know how to check it?
Yes.
How do you check it?
You have to multiply.
Turn your TV down.
339 and 4.
You have to multiply 339 and 4, you said?
Yes.
Why are you multiplying by 339?
Because the 739 is your quotient.
Well, what is the definition of a quotient?
The number that you're dividing by?
No, the quotient is the answer to a division problem. So in this case...
Oh, that's a dividend.
There you go. So 105 is your quotient. Remainder 4. So you have to take your quotient and do what with it? You have to multiply by that 7. So 7 times 5?
It is 35.
So 5 goes in the 1's place, the 3 goes in the 10's place. 7 times 0 is 0, plus that 3 10's gives us the 30, and now we have 7 times 100 equals 700. But this should match this, so what else do we have left to do?
We have to add the remainder.
Add the 4 remainder. 5 plus 4 is 9, 30, 700. Now this looks like this, and we have checked it, so we know it's correct. So your answer is 105, remainder 4. Is that helpful?
Yes.
Okay.
All right. Did you want to try one of the challenges? Felicia?
Yes.
All right. Take a look at the challenges. Card A, B, C, or D. Which one would you like to challenge yourself with?
B.
B as in boy.
Ooh.
8, 8, 4, 7.
Yes.
Okay, 8, 8, 4, 7. And we would like a total of 24, Felicia. Okay, can you help me out with that?
I think we can add them together.
Okay, well, what would you like to add?
We can add 8 plus 8 equals 16 plus
8.
4.
Wait. Slow down. 8 plus 8 equals 16. Okay, so I've used my 2 8s. Now I have to use my 4 and my 7. Okay, 8 plus 8 equals 16. Now what?
We're gonna add the 7.
Okay, so 16 plus 7. How much is 16 plus 7? How much is 16 plus 7?
Oh, 23.
Okay, 16 plus 7 is 23. So we've used our 7. How many more do we need to get from 23 to 24?
1.
And how many more do we have to use?
4.
So what shall we do with that 4? Should we add it, subtract it?
Subtract it?
Okay, if we subtract 4, will we get a total of 20? What total will we get?
19.
Yeah.
And wow, we are a little bit short of coming up with our total of 24. But Felicia, your name is going into the apple, our treasure chest, because we do treasure all of our callers that call, count on us. I want you to think about it because with mathematics, we want to persevere. That means keep on trying. If the first time you don't get a correct answer, it's okay. You just learned one way that does not work. But there is a way that will work using these 4 numbers. So we're going to be right here waiting for you, Felicia. Wow, so close.
That was
really,
close.
really close.
And that's why you have to have multiple strategies.
Multiple strategies, meaning more than one way?
More than one way, absolutely.
That's incredible. You do need to have more than one way of solving a particular problem.
There you go.
So, hey, what about those fraction sandwiches?
What about those fractions? You must be hungry. Did you eat lunch today? You're asking for sandwiches.
Fraction sandwiches.
You've been talking about eating for quite a while now.
Well,
isn't it
almost dinner time?
Is it?
Well,
okay.
I got it. I have to go home and cook first.
Well.
So it's not quite. Okay, go ahead.
Okay,
I'm going to focus.
Please.
Focus.
Enough of the food already.
Okay. So what do you do? How do you know which ones go where?
So they're color coordinated.
Color coordinated.
Makes it easier. And what happens is this blue one is one whole.
One whole.
And each color has a relationship to the one whole.
What do you mean by relationship?
Very good question. So I can take one whole and I can break it in half.
Okay.
Half or 1/2.
Ah, okay. 1 out of 2?
1 out of 2.
Okay.
So it's still the same size. If I put this right on top here, it's the same thing. It's kind of like if I take a Kit Kat bar and I want to share it with you.
Oh, would you please?
Because you're so hungry, I would do that.
Okay.
So here, I could take this one whole, I could break it up into 2 equal parts.
And then, so does that mean I would get 1 and you would get 1?
I'm glad you're sharing. You're sharing. Yes, we would each get a piece. Now, let's say we had another friend here.
Okay.
We could take this same one whole and break it into 3 equal parts. Look at that. Yummy, yummy. Look at that.
Oh, Jolly Ranchers. Apple Jolly Ranchers. Ooh.
Good thing Halloween is coming up. Make sure you have a big bag.
Apple Jolly Ranchers.
Yum, yum.
Ooh.
Are we going to associate everything here with candy today?
Well, you said I couldn't make a sandwich, so.
Okay.
Didn't you say I couldn't make a sandwich?
I didn't say you couldn't. I was just wondering why, stress of food so much. But,
Okay, all right.
If you're hungry, you're hungry.
Okay, so then what is that?
We could take this one whole and break it up into 4 equal parts. Look at that.
4 equal parts.
Right, so if we had 2 more friends, like our camera people over here, they could get a piece as well.
All right.
The only thing is, each of our pieces is a little smaller.
Oh, okay.
And that's what happens. So
what happens?
the more pieces that you break it up into,
the
smaller the pieces.
Each
so
part gets smaller.
Here, this was half, this was a third, this was a fourth. So each piece gets smaller and smaller. So the next one would be our... Let's see if they're in here.
What's this red one? This red one's looking pretty small.
Oh, I'm looking for...
I guess we don't have
6.
any. Okay, let's see. The red is small.
Yeah, it is, but before we get there...
Okay.
Let's
well,
get
do
to
we
our,
have enough?
Let's get to our 6.
Okay. Now, wait a minute. How do you know what to call it? How did you know it was a 6?
I like your question. So,
How did you know it
what's
was...
actually happening is,
Okay.
if I take this whole, I can break it up into 6 equal parts, and that's why it's called a sixth. Because it's 1/6 of the whole amount.
So if I count them up, let me see if I can count them.
Count 'em.
1, 2, 3, 4, 5. Oh, it's magic.
Look at that. Look at that.
And
Look at
what?
that.
How did you know?
The cool
You're just
thing-
so smart, Mr. G.
The cool thing is, they're all the exact same size, and they all equal that one whole.
Now, is it so? I heard somebody say a fancy word, meaning they're all the exact same size. I forgot what that fancy word was, though.
It's a fancy word. Was it a C word?
I think it was an E word.
Oh, the E word.
The E word.
The E word. The E word is equivalent.
Equivalent.
Ooh.
Wow.
Look at
Okay.
Look at that. Isn't that
So
lovely?
what's C word though? Now you have me curious.
I was going to say
only know-
congruent because, you know, the same size, same shape.
Oh, that means congruent. Okay.
But
Well,
equivalent is perfect.
equivalent is a good word too. So we have E words and C words
Yeah.
for fractions.
For fractions, well, typically we talk about equivalencies when we're talking about fractions. But if you looked at just the shapes, students would say, well, they are congruent because they're the same size and the same shape.
Oh, okay. They
As
all
opposed
make
to
rectangles.
There you go. Well, not all of them make rectangles because these make squares.
Oh.
Look at that.
Oh, they do?
Hmm.
Okay. And now, wait a minute. That looks like a rectangle to
Look
me.
at that. Look at that. No, I'm saying these shapes right here. Look at this. They're squares.
Oh, those shapes. Oh,
Woohoo.
my goodness.
We have another caller.
Oh, we have another caller.
Ah.
Is this Sharon? Sharon, how are you? Sharon? Welcome to Count on Us, Sharon. Now, I'm so happy that you called us today. Do you have a math homework question?
Yes.
What grade? Okay, before you ask your math question, I have 2 questions that you must answer. Question number 1. What grade are you, Sharon?
Could you repeat that, please?
Absolutely. Sharon, can you tell me what grade you're in? What grade are you?
I'm in 4th grade.
Fourth grade. That's a good grade, Sharon. And would you like to give a shout out to your school?
Yes.
What school do you attend, Sharon?
Magnolia Elementary.
All right.
All right, Magnolia Elementary. Yay! And one more. Would you like to give a shout out to your teacher?
Miss Fernandez.
Miss?
Mrs.
Mrs.
Fernandez.
Mrs. Hernandez.
Well,
Very
a
good.
shout out to Mrs. Hernandez
Yeah.
as well. And you're in 4th grade, and what is your math homework question? And Mr. G and I will both assist you if necessary. What are you working with, Sharon?
The different kind of properties.
Okay.
Okay. Well, what do you know about properties?
I know that there is there is.
Do you know that properties are rules?
Yes.
Okay. So, is there a particular math property or math rule that you were working with? Or what exactly was your...
I'm working on all of them.
All of the properties. Oh, wow. There's a lot of properties. Which one would you like to focus on right now? So what do you have to do? You have a problem and you have to tell which property you can use to solve it? Or you have a property and you have to identify the problem? What exactly is it that you're doing today?
Could you please repeat that?
Do you have the property, the name of the property already, and you have to give a problem to match it? Or do you have a problem that you have to match with the property? Which way are you working? Or do you have to create your own to make a property?
The 3-second one.
The 3-second one. Okay, can you give me an example of the 3-second one? Are there particular numbers that you're using?
I'm using
Is this from a worksheet or in your book?
actually my teacher has it.
Okay. Well, if you will give me a hint, I will try to work with you. Are there particular numbers that you're using?
I'm working on the 5.
Okay.
5.
Number 5 in your book?
Yes.
So what does number 5 in your book say? Can you read it exactly as it is in the book?
I don't have the book with me.
Oh, guess what, Sharon? I don't have the book either. So how am I going to help you? Do you have it written down? Okay, so let's just say that you had, 5. I don't know if you tuned in earlier when we had the stars and the circles and stars.
Sharon, are you there?
Hello?
Okay, 7 times 5 is this equal to the exact same thing as, 5 times 7 is equal to the exact same thing as 7 times 5. Do you agree with that statement, Sharon?
Yes.
What's 7 times 5?
35.
Very good.
Excellent.
And what is 5 times 7 is 35. So what's 7 times 5?
35.
Very good.
Excellent.
Because these two are equal to the exact same amount. This is called the commutative property. Have you heard of that property before?
Yes.
TA.
Okay, so were you using that type of property? Was that one of the properties you were using?
Yes.
Okay, so that's one of the rules, that when I'm multiplying or adding, I can switch the order around and I will still get the exact same answer. Now let's add one more to this. What if I had 5 times 3 times 2, and I wanted to use my grouping symbols. My grouping symbols are called parentheses. And what if I wanted to say 5 times grouping symbol? Okay, what did I change in that particular problem?
Could you please repeat that?
Okay, look at what's different. I used my parentheses. First time when I used my parentheses, it was around the 5 and the 3, which means I'm going to multiply those first. So 5 times 3 is 15 times 2, which equals 30. The second time around, I put my grouping symbols around my 3 times 2, which means I'm going to do that first. 3 times 2 is 6. 5 times 6 is equal to 30. So again, those are equal to the exact same thing. And that math rule is called the associative property. So those are two of the math rules that are used quite frequently to help you to solve problems. So using your properties is a strategy to help you solve math problems. Sharon, does that help out?
Yes.
All right. Sharon, guess what? It's almost the end of the show. So your name is going into the treasure chest because we treasure all of our callers that call in today, and we thank all of our callers for calling in. And it is time for a fabulous and the winner
teacher.
We would like to thank all of our callers for tuning in this afternoon. Remember, each Monday and Wednesday from 4 to 5, your elementary hosts will help you with any math homework that you might be having, because each and every Monday and Wednesday, you can always count on us.
Welcome to your mini lesson today. My name is Mrs. Jacks, and today we will discuss how to change mixed numbers into improper fractions, and the reverse of that, how to change improper fractions into mixed numbers or whole numbers. Let's go ahead and look at an example. In this example here, once again, it says changing mixed numbers to improper fractions. We have a mixed number here. A mixed number is when you have a whole number paired with a fraction. This one happens to be 3 1/8. We're going to go ahead and change that into an improper fraction. The first step is to multiply the whole number by the denominator. So 3 times 8 is 24. After you do that, well, let me go ahead and show you. 3 times 8 equals 24. You have the numerator here. We're going to go ahead and now add the numerator to our product. 24 plus 1 equals 25. This final answer becomes your new numerator, and the denominator stays the same. So 3 1/8 changed to an improper fraction happens to be 25 over 8. An improper fraction means that the number on top, which is the numerator, is greater than or larger than the number on the bottom, which is the denominator. We can also reverse this. We can change improper fractions back to mixed numbers, and I'm going to show you how to do that now with this second example. Changing improper fractions to mixed numbers or whole numbers. This first one here is an improper fraction. Once again, that means that the numerator is larger than the denominator. The first step is to divide the numerator by the denominator. Okay, so I'm going to set this up as 56 divided by 7. If you already know the answer, you can of course put the answer here, or you can set it up the long way using an algorithm. 7 goes into 56 8 whole times. 8 times 7 is 56. And then with the algorithm, you will go ahead and subtract, and your answer is 0 here, so you don't have anything left over. There's nothing else to continue dividing by. So your answer happens to be 8. So in this case, you can change an improper fraction to a whole number. Let's look over here. This one is a little different. This is 55 divided by 7. So it's one number less than 56. Let's see what happens when we do that. 55 divided by 7, we will do it the same way. 7 goes into 55. It doesn't go exactly 8 whole times. It's going to go in 6 times, and then we're going to have something left over. So let's go ahead and set up the algorithm. 55 divided by 7. Well, I'm sorry, I said 6 times. Excuse me. It goes in 7 whole times. So 7 into 55 is 7. 7 times 7 is 49. To complete the algorithm, you need to go ahead and subtract. 55 minus 49 gives you 6. So 6 is your remainder. Now, to set up our answer, the whole number here becomes our whole number for the mixed number, and then the remainder becomes the new numerator, and guess what? The denominator stays the same. So 55 sevenths, which is an improper fraction, now becomes 7 6/7 as a mixed number. Once again, this was a short mini lesson on changing improper fractions to mixed numbers and changing mixed numbers to improper fractions. Thank you for your time.
Minds can achieve anything. We make sure they get to college. student aid provides more than $150 billion in grants, loans, and work-study funds to make college possible for anyone with the mind to get there. Because if given the chance, minds will do great things. Federal Student Aid, proud sponsor of the American Mind. Learn more about money for college at studentaid.gov.
Because how many ways are there to solve math?
Many! Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself.
So the second equation for solve perimeter is
2 times length plus 2 times width.
Welcome back, you lucky viewers. This is the second half of our Count on Us TV show. This is the intermediate level, and we're going to have questions that are from middle school on up to high school, college, and advanced degree level. My name is Ted Herman.
And I'm Mr. Belton. Welcome, boys and girls, to the secondary edition. Remember that you can call us at 301-772-0080. Remember also that the show airs on Comcast Channel 96 as well as Verizon Channel 38. If you have neither Comcast nor Verizon, you can catch us on the web at PGCPS.org.
Excellent.
So, Mr. Herman, how was your day?
Oh, it was spectacular.
Pretty good day?
Oh, it was the best day I've had my whole day.
Best day you've had your whole day?
Yes, as I remember, it was a good day. We did a lot of testing and getting ready for the new park test.
Okay, well, looks like we have our first call, so caller, are you there?
Oh, we haven't done the challenge yet. Let's
do
do
the 24. Let's do the 24.
Yeah, let's go look at the 24 challenge, because viewers, if you get a chance, write these numbers down. If you find a good combination of using all 4 numbers in the circle to make 24 happen after adding, subtracting, multiplying, dividing. So, Mr. Belton, you want to take over this 24 challenge bit?
We have card A, we have 2 8s, 7 and 3. We have card B, 2 8s again, 1 and 5. Card C, we have 4, 5, 6, 8. Card D, we have 3, 4, 7, and 9. The dots in the corners represent the difficulty. 1 is the most straightforward, 2 being intermediate.
Excellent. Now, while you're at it, we're going to look at another challenge you can call in on. And this is a mind builder because it makes you think at a higher level, and you have to use all those clues to figure out which number we're trying to think of.
Name the mystery number. It is between 40 and 50. It is not divisible by 2. It is not divisible by 3. It is not a prime number. So those are your 4 clues that you want to utilize to identify the mystery number.
I like that word, utilize. That's a heavy-duty math word. Now, let's go to our first caller. We want to take the first caller, Mr. Belton?
First caller, are you there?
Aaliyah?
Hello?
Aaliyah?
Hello?
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 Are you there, Aaliyah?
Hello?
Hello? Hello?
Hello?
Hello? Hey, Aaliyah. Yeah, turn that TV set
turn
down.
the TV
okay?
down
You can hear
for
us
us.
better.
Yeah, turn the TV.
Yeah. Because I think you're at Gwynn Park Middle, so I bet you know Mr.
Gwynn
Belton.
Park Middle School. Hey, we have a caller. Aaliyah, you there?
I'm calling for proportion.
Okay, how can we help you? What's your question?
Bianca has a photo that measures 5 inches wide by 7 inches tall.
Okay, Bianca has a photo that measures 5 inches wide by 7 inches
tall. 7
tall.
inches tall.
Okay.
What is this thing called?
If she wanted it to fit into an 11 times 14 frame, would it work?
You have 5 inches by 7 inches.
Yes.
Okay. And what's the remainder of the question?
If she wanted it to fit into an 11 times 14 frame, would it work?
Is it 11 inches? Ali, what are the units for the second ratio you gave?
11 by 14 frame, would it work?
11 by 14.
Yes.
Okay.
No, I'm just saying, was that inches or centimeters or what? Still inches on 11 and 14?
Yes.
Well, which one would you want to do on this? I mean, it's your question, Mr. Bell. I don't want to hog it, but Aaliyah, what are you thinking about doing with this? You looking for perimeter or area or what?
Turn it into a fraction. So.
Well, you have 5 over 7.
Oh, I think I got what she's talking about. 5/7.
And that's going to be equivalent to?
There you go. 11.
What over 14?
Yes.
And I think, let me see. If we have 5/7, that would be equivalent to what over 14, Aaliyah?
But you know what? We can go ahead and master this right now, then find out more about what would actually be a good ratio proportion. Is that cool? So what, Aaliyah, can you do cross multiplication? What's 7 times 11?
77.
Excellent. And then what's 5 times 14 cross multiply?
14 times 5 equals 20. Okay. Shut up.
I didn't say anything.
70.
Good. So are those equal? 77 equals 70?
Yes.
They're equal?
77 and 70?
Yes. No.
No. So that would not be a proper proportion. Like Mr. Belton was trying to do, he was trying to find out what would be the proper proportion. So Mr. Belton.
So what would that value of X have to be? If I had 5/7 equivalent to X over 14. How do I solve for X?
Cross multiply.
Okay, so let's take our first cross product. We have 7 times X. What's that equal to?
7 and X in front of 7.
Okay, so 7X. That's going to be equivalent to 14 times 5.
70.
70. Now, Aaliyah, what kind of equation is this?
A proportion.
A proportion, but after exhausting the first step where we cross multiply, what operation is this? 7 and X side by side.
What's it called? Algebra.
It's an algebraic equation, but what operation is involved? 7X. Is that addition, subtraction, multiplication, or division?
Multiplication.
What's the inverse or the opposite of multiplication?
X by itself.
How do we get X by itself? Performing what operation? What's the opposite of multiplication?
Division.
Division. What do we want to divide both sides by?
7.
7. So when we divide both sides by 7, we see that x equals 70 divided by 7. What's 70 divided by 7?
10.
10. So in order for that frame to fit, the dimensions will have to be what? Not 11 by 14, but what?
10, okay.
10 by
10 by 7.
Not 10 by 7. Instead of 11 by 14, the dimensions of the frame will have to be
14.
10 by 14. Because those two represent a proportional relationship. If you look back at the previous example, you notice that the two cross products here are not equivalent. So you have 77 with one cross product and you have 70 with the other. You see that?
Yes.
Now, if you look on the flip side, if we were to do 5/7 compared to 10/14, let's do the cross products now. What's 10 times 7?
10 times 7. 70.
70. And what about 14 times 5?
70.
So what do we see now?
I got it.
That our cross products are what?
Equal.
Equivalent or equal. So these two form a proportional relationship.
Way to go, Aaliyah. She got her name in the drawing one time.
Does that help you, Aaliyah?
Yes.
You want to try a 24 challenge before we let you go?
Yes.
Okay, we have another caller, so we're going to ask you to write down the 4 numbers from whichever card you want to try. You have A, B, C, or D. Which one would you like to try?
4, 5, 8, and 9.
That's actually a 6. If it's shaded in red, it's a 9. If it's not shaded in red, then it's a 6. I know it looks like a 9, but that's actually a 6. So card C?
Okay.
Card C?
C, yes.
Okay, so you have 4, 5, 6, and 8. Give us a call back when you get 24, all right?
Okay.
Good job.
Good talking to you, Aaliyah. Nice job there at Gwynn Park Middle.
Hey.
And let's go to our next caller out there in TV land. I think we have Montana. Montana, you there?
Yes.
Oh my goodness, Montana, I know you. Are you at Mount Rainier?
Yes.
Oh my God, are you in my math class?
Yes.
Oh, Montana.
You got one of your students.
Oh, I'm
okay.
excited. Montana Nelson?
No.
I didn't think so. But it's in Montana. That's all I care about. And you're calling in with a math problem?
No. Yes, a word problem.
Oh boy, I like word problems. They're kind of interesting. Let's see what it's all about. Go ahead, Montana. Read it out nice and proud.
The school is buying new art supplies for each of the 16 classes. The art supplies cost $88 per class. About how much will the school spend on new art supplies? Round to the nearest 10.
Beautifully read. I can already tell Montana is one of my top students. She is so sophisticated and so sharp. Now, Montana, let's see if you can help our viewers a little bit. Are you saying there's going to be 16 different classrooms going to get their art supplies?
Yes.
So there's a 16. And what did we say in class about that $88? Is that the way to write $88, or is there a better way to write that $88 there? What can we put
What did you say?
What can we put next to the 88 on the right-hand side to make it a really official dollars and cents? That says $88, but to really be the way we do in the real world, what's this called right here?
The decimal point.
Excellent. Then what do I put after that? 2 what?
0, 0.
That's my girl. That's what we do. Now I'm going to put the 16 right below it, but we haven't figured out what operation, except I did hear you say the word per. Do you know what per means in math?
Each.
Oh my, I told you Montana was one of my best. She listens and she learns. and then she remembers what she learned after she listened to what she learned. You know what I'm saying? Sort of? Okay, each. So when we have each in a math word problem, do we add, subtract, multiply, or divide?
Add?
Well, that's right. We definitely would not want to add. What else would we not want to do?
What's a faster way to add, Montana?
What did you say?
What's a faster way to add?
Multiply.
Ah, she must speak the way you're speaking beautifully. She picked up on it really fast. Nice job, Mr. Bell. Way to give a good clue. So, Montana, show everybody your multiplication skills at Mount Rainier Elementary School and Prince George's County Schools. 6 times 0.
0.
6 times 0.
What? 0.
How about the decimal point? Where do I put that?
Right in front of the 0.
I love Montana style. Now, comes a tester. 6 times 8.
48.
I love it. Where's the 4 going to go? I put the 8 down. Where's the 4 going to go?
On top of the 8 next to the dollar sign.
Uh-huh. And 6 times 8 again is 48 plus 4 more.
52.
I love Montana. So what we're going to do, we're going to get the exact answer with numbers, but then we're going to do the about, which is estimate. We'll do that in a few minutes. So let's go real fast, Montana. We're going to put a 0 down because we're not multiplying by a 1. Where is that 1? What column?
What did you say?
Where's that 1 located? Is that the 1s or the 10s?
The 10s.
Yes. And anything multiplied by 10s means you put a what on the end? What do you put on the end of the number?
I didn't hear you.
That's okay. I don't understand it myself. When you multiply by anything with a 10, don't you put a 0 on the end of that?
Yes.
Gosh bless you. So now let's go. 1 times 0 is 0. 1 times 0 is 0. 1 times 8 is 8. 1 times 8 is 8. Now, Montana, go ahead and add up great. 0 and 0?
0.
0 and 0 makes 0. How about 8 plus 0?
0.
What? 8 plus 0? We're adding now.
Huh?
We're adding.
8 plus 0. Oh, I thought you said 8 times.
No, plus. Add.
Yeah. 2 plus 8 equals 10.
You mean 8 plus 0 is 8, and 2 plus 8 is 10. Okay? And then 5 plus 8 is what? You know that? With the 1 added on, it's 14. So, we would get $1,408 to have to purchase these 16 classrooms of art supplies. But didn't we say the word about? And I think you said round it up to the nearest 10. Nearest 10, thank you. So, what is $88 rounded up to the nearest 10? Can you estimate it to either 80 or 90?
90.
Yes. Okay, so we're going to put $88 becomes 90. Why'd you go 90? How do you know it's 90? You went over to the tens place.
Because 88 is closer to 90 than 80.
Excellent job. And then 90 multiplied by 16, we can make 16 into what? What's a close number 16? What 10? 10 or 20 or 30?
20.
Yes. Yes, you nailed it. Let me show you a shortcut. What's 2 times 9?
18.
Oh, Montana, you're golden. You're golden. And then 1, 2, 3, 4 zeros. So 1, 8, 1, 2, 3, 4. So it would be around $1,800. But the real answer was how do you say this number right here, Montana? 1,000 what?
1,408
What?
dollars.
Excellent. And that'd be the actual cost.
Now, Montana, if you had to round this amount to the nearest 10, what would that be? $1,408.
Mm.
1,410.
$1,410. Very good, Montana.
She is sharp. And her name's going into the treasure chest one time.
It's already in there. Montana, you want to try a 24 challenge before we let you go?
Or the Mind Builders.
Yes, the 24 challenge.
The 24 challenge.
And this is the card right here.
Okay, we have another caller that we need to take, Montana. So, which card would you like to try? A, B, C, or D?
A.
Card A, we have 3, 7, and 2 8s. Write those 4 numbers down. See if you can get 24 and give us a call back, all right?
Okay.
All right. Good job.
Thank you.
And Montana, you're a pleasure to talk to. And I'll tell you, she was one of our stars last year of our winter show. She was on the stage. She had the lead part in a major show we did.
Next caller, are you there?
Hello?
Next caller, are you there?
Hello?
Hello?
Hello. Hello.
Is this
Hello.
Daryl?
Hello.
Daryl, what school do you attend?
Hi, Mr. Belton.
Hello, Daryl. What school do you attend?
Gwen Park.
Gwen Park Middle School. Hey, we have another caller.
She say Gwen Park or
Gwen Park.
I was say Grandpa.
She's one of my students.
Oh, one of your students. What grade? 7th or 8th?
8th grade. Daryl, what's your question?
My question
what's your question?
is, okay, is Alberto and, it's a word problem.
Okay.
It's Alberto and Ashanti are reading graphic novels. And for part A, it says write an equation to represent the pages each boy has read. So Alberto has read 35 pages and 20 pages each day, and Ashanti read 85 pages and 10 pages each night.
Okay, let's stop there for 1 second. Do you have the equations for Alberto and Ashanti?
For my equation, I wrote 35x plus 20y for Alberto, and for Ashanti, I wrote 85x plus 10y.
Okay, that's close. Are you watching the show, Daryl?
Yeah.
Okay, for Alberto, we know he starts with 35 pages, correct?
Yes.
And he's reading 20 pages each day.
Yes.
So, that equation is going to be modeled with y equals 20x plus 35. 20 pages each day, in addition to the 35 pages he's already read. You with me so far?
Yes.
Okay, now Ashanti, he's already read 85 pages?
Yeah, Ashanti read 85 pages and 10 pages each night.
Okay, so Ashanti's equation is going to be 10x plus 85.
Okay.
Now, you're trying to determine how many days it's going to take Alberto to surpass Ashanti?
Yes.
Okay, so what we're going to do is set up one of our views of a function, which is a table. So, we're going to start with x, and off to the side here we can note that x represents days and y represents pages read. You with me so far?
Yes.
And hopefully your classmates are watching. It's not every day you get to get your homework done live on TV. So, all right. So we have, here's our table. We're going to start with 0 days, and we're going to continue until we identify how many days it takes Alberto to surpass Ashanti? So, here's Alberto. Here's Ashanti. 0 days. How many pages has Alberto read?
You said on day 0?
Day 0. He's already read how many pages?
0? No, 35.
35. What about Ashanti?
85?
85. And Alberto is reading how many pages each day?
He's reading 35 each day.
Not each day. He starts with 35 and he's reading how many each day?
20.
20. So after the first day, he's read
55?
55, then?
Then 75?
Then?
95?
Then?
115?
115.
Then 135?
135, and then?
155.
155. Okay. Ashanti is reading how many pages each day?
10?
So after 85, we have?
95?
Then?
105?
115, 125, 135, 145. Daryl, I have 2 questions for you.
Okay.
After how many days does Alberto and Ashanti read the same amount of pages?
Probably. Wait.
If you're looking at the TV, the answer's looking right at you.
Oh, day 5.
After 5 days, now I know this is not part of the homework question, this is just a follow-up question. After 5 days, Alberto and Ashanti have read the same amount of pages. Now let's get back to the question. After how many days does Alberto surpass Ashanti?
Day 6.
Day 6. After 6 days, Alberto has read how many pages?
He has read 155.
155, and Ashanti has read how many?
145.
145. Does that help you out?
Yes.
You sure?
Yes.
Okay, you want to try a 24 challenge before we let you go?
Excellent job. That's a nice table and chart.
Yes.
Do you one favor, Daryl. Notify Alberto his library book's been overdue for a month. He's up to $100 in fines. So get that library book back. If you see Alberto in the hall.
Okay, Daryl, here's the 24. Which card would you like to try? We have A, B, C, D.
Can I do C?
You sure can. You have 4, 5, 6, 8.
Okay.
Now write those 4 numbers down, Daryl, and give us a call back because we have to take a short break. All right?
Okay.
And because you called, no more homework for the rest of the week for you.
Wow. Oh, thanks.
See you tomorrow.
We're going to go to a short commercial break. Stay tuned and watch some more math, and then come back to the second half of the show.
We'll be right back. Call us. Stay on the line.
Hi, I'm Cameron from Samuel Ogle Middle School, and today's email question is from Ted at Rockledge Elementary. Ted wants to know the area and perimeter of a rectangle that measures 3 inches by 6 inches. Well, let's start with the perimeter. The perimeter is around. So we add all the sides. Okay, so we know that if 3 inches is on this side, then 3 inches is on this side. And if 6 inches is on this side, 6 inches is on this side, because the opposite sides are equal. Now we add 6 plus 6. 6 plus 6 equals 12 inches. And 3 plus 3 equals 6 inches. Now 12 plus 6 equals 18 inches, which is the perimeter. Now we do the area. The area is the inside. So we can either count the squares or we can do length times width. And the length would be 6 inches and the width would be 3 inches. So let's do both. First, we'll count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now we know that we have 18 inches squared since we used the squares. And the same thing goes for length times width. So now we do 6 times 3. 6 times 3 equals 18 inches squared. And this is the area. Well, Ted, I hope that was helpful to you. So that's Cameron, and see you next time.
Wait a minute. That's wrong. All people are people.
Take the time to get to know people, and you'll see that all of these labels are false. Don't let prejudice shape your view. Stereotyping is wrong, and it hurts all of us.
Stop stereotyping.
A message from your American Muslim neighbors.
When I was a kid, I dreamed of being a stuntman.
I went from dream to dream pretty quickly. I wanted to be a cowboy. Tom Cruise in Top Gun.
I dreamt of being a nun.
Actually, before that, it was Popeye.
Malaria kills more than 2,000 children a day.
Text NET, N-E-T, to 85944 to make a $10 donation to Malaria No More.
Oh, messaging and data rates may apply.
Let's make malaria no more.
Welcome back to the second half of the intermediate show. I'm Ted Herman.
And I'm Mr. Belton, and we are here to answer your math questions for the remaining time. So please do not hesitate to give us a call.
And we've had callers off the hook all over the place.
Waiting patiently, too.
I tell you, let's get right to the next caller. What?
Okay, next caller
is Janice. Janice, you've been waiting a long time. How you doing, Janice? Hello?
Good.
What school you at, Janice?
Huh?
What school do you go to?
Kettering Middle School.
Fantastic. Right down the road. Okay. And what grade are you in?
7th.
And you have a good 7th grade math question for us today.
I need a review for finding proportions.
Okay.
Yeah, you have a particular question for us, Janice?
If to find if fractions are equivalent, like 3/4 over and equal 12/16.
Okay.
All right, good. I'm glad to see you came ready with a good question for us. Let's go about seeing if they're equal or not as far as proportional. Now, you know that's a ratio. 3/4 fraction is a ratio. And this is a ratio too, 12/16, and the equal sign in between it makes it a proportion. So the whole problem is a proportion. And you heard about cross multiplication?
Yes.
So what do you do with cross multiplication? 3 is going to multiply the what?
3 and 16.
Excellent, Janice. What's that make? Do you know?
That 3 times 16.
Are you working it out, Janice?
Yeah.
Okay.
48.
48. Very good.
Excellent.
So that's one cross product. What about the other cross product?
What's 4 times 12, Janice, so you can do it in your head?
48.
Excellent. So, what would you say about those two numbers?
They're equivalent.
Yes, which makes this whole proportion equivalent. So you did a great job setting it up. I think you already have a pretty good idea about proportions already. All right. Any other question about proportions you want to get answered before you want to try a challenge problem?
No.
You want to try a challenge?
I mean, yes.
Yes, you do want to try a challenge.
You want to try the 24 challenge, Janice, or the Mind Builders?
24.
24
Okay.
challenge, okay.
And you got your name in the drawing already one time. If you can solve one of these, then you'll get it in a second time. Which letter do you want to go with? A, B, C, or D?
B.
B is in boy?
Yes.
Okay.
So you have 2 8s, a 1, and 5, Janice. Do us a favor because we have another call. Write those 4 numbers down and see if you can come up with 24 and give us a call back, all right?
Okay.
All right, good job.
8815.
8815.
Nice job, callers.
Next caller, are you there? Next caller?
Hello.
Hello?
Hello.
Is this Stephen?
Yes.
Stephen, what school do you attend?
Gwen Park Middle.
Gwen Park Middle School. All right, Stephen, thank you for calling us. How can we help you this evening? What's your question?
I need help on a fraction with exponents.
All right, you have a particular example?
Yes.
What's your question?
1 over 4 to the negative 5th power times 1 over 4 to the 8th power.
So you have, are you watching the show, Stephen?
Yes.
You have 1/4 to the negative 5th times 1/4 to the 8th. Is that correct?
Yes.
Okay, now, do you know which rule we're going to apply to evaluate this expression or simplify this expression, Stephen?
Yes.
Which rule?
Addition.
Now, we will be adding, but the rule is called the product of powers rule.
Oh,
Now,
multiplying.
the product of powers rule says anytime we have the same base, what's our base, Stephen?
4.
Not 4. The entire fraction is our base. 1/4 will be our base. So when we have identical bases, we multiply the powers by doing what to the exponent?
Oh no! It's 1 over 4 to the 5th, not 1/4 to the negative 5th.
Okay.
So 1 over 4 to the 5th. It's like it's a power right at the denominator at the 4.
So this. Are you watching?
Yes.
So is it this?
Yes.
And you have to evaluate that?
Yes.
Is that it?
It's just, yeah.
You sure?
Yeah.
Okay.
What happened to the 1/4 to the 8th power? Is that gone?
It's the same thing. It's 4. It's not a negative. It's 1 over 4 to the 8th.
And what are you doing with that? Multiplying or adding?
Multiplying.
Are you watching the show?
Yes, but my computer is a little slow. Like,
okay.
It's
So
behind a little bit, so I can't see.
You have 1 over 4 to the 5th.
Yes.
And then you have this multiplied by 1 over 4 to the 8th. Is that it?
Yes.
That's it?
No, no negatives. Okay.
Okay, so now, we still apply the product of powers rule to the denominators, and that will give us what? What do we do with the 5 and the 8?
We add them.
And that gives us what?
13.
So, our final result will be what?
4 to the 13th power.
Well, that would be the denominator. What would the numerator be?
1.
1. So, let me just clear that up real quick. So, we have 1 over 4 to the 5th times 1 over 4 to the 8th, which is equivalent to 1 over 4 to the 13th.
Nice job, Stephen.
Does that help you out, Stephen?
Yes.
All right. You have any other questions?
Yes, it's another problem.
Okay.
It's 2 to the 6th power over 2 to the negative 8th power times 2 to the 10th power.
Okay. You still watching?
Yes.
You said 2 to the 6th divided by 2 to the
8th. Negative 8th.
negative 8th times
2 to the 10th power.
2 to the 10th. Is that it?
Yes.
Okay, the first thing we want to do is apply the quotient of powers property. What do we do with 6 and the negative 8?
You gotta subtract. Wait.
That's right. You have to subtract. Now, what's 6 minus a negative 8? Remember, to subtract an integer, we add its opposite. So to subtract negative 8, we add positive 8. So what would that be equal to?
Negative 14.
Not negative 14. This is just 6 plus 8.
Oh, 14.
14. So now we have 2 to the 14th times 2 to the 10th. Are the bases the same?
Yes.
So what do we do to the exponents?
You add them.
So 2 to the 14th times 2 to the 10th will be equal to?
2 to the 21st power.
Not 21st. 14 plus 10.
Oh, 2 to the 24th power.
2 to the 24th power will be correct. Good job, Stephen. Before we let you go, you want to try a 24 challenge?
Yes.
All right. We have a couple of calls that we need to take, Stephen. So do us a favor and write down the 4 numbers from the card that you want to select and give us a call back once you get 24.
Okay.
Which card do you want to try?
All right.
You got A, B, C, D.
A.
A, you got 2 8s, 3, and 7. See if you can get 24 and give us a call back.
Okay.
All right.
2 8s, 3, and what?
7.
7.
3,
Okay.
7, 8, 8.
3, 7, 8, 8.
Okay.
Good job, Stephen.
Nice job. Let's go to the next caller out there. I think it's Cameron.
Yes.
Cameron, you called back.
From Mount Rainier. That's the school, right?
Who's your math teacher there, Cameron?
Huh?
Good. And it's good to have you on the air. Why'd you hang up before? We were all excited about getting you on. Where'd you go?
The phone died.
Okay,
Oh,
well, he's
sorry.
back.
Well, I hope it came back to life. And now you're back on the air. So what kind of math problem do you have, Cameron?
A multiplication one.
Okay, let's hear it.
It's 2,724 times 42.
Wow. 2,700 what?
24.
Multiplied by what?
42.
Thank you for that great problem. And you too, Mr. Belton. Well, you know what? I better move it down a little bit, make sure I get it more centered. 2,724 multiplied by 42. All right, where are we going to start here, Cameron?
Oh,
Can you do 2 times 4 for us?
8.
Yes, I know you know your facts, Cameron. You're sharp. 2 times 2.
8. 2 times 2 is 4.
Right. 2 times is 7.
14.
And carry the what?
Well, put the 1 on top of the 2.
You got that right.
Very
and then
good.
2 times the 2.
4.
Plus the 1.
5.
And you are on top of your skills. Now, what do we get rid of up top?
Get rid of the 1.
Thank you for paying attention in our class, Cameron. You know a lot. Now, why am I putting a 0 down here in the second row?
0.
What are we multiplying now?
4 times 4.
But what's that 4 worth? It's not really a 4. It's a 4 in the what column?
In the 10 place.
Yes. And anything times 10 gets a what on the end?
0.
You got it,
Very
Cameron.
good.
4 times 4, buddy.
16.
And then carry the 1. What's 4 times 2?
2 times 4 is 8.
And 1?
Is 5. It's set 9. 9.
Right. And then 4 times 7?
Is 28.
Put down the 8, carry the 2. And then 4 times 2?
2 times 4 is 8.
Plus 2?
10.
Man, Cameron, you're sharp. 8 plus 0. Let's go, buddy. Wrap it up.
8.
4 and 6.
10.
Carry the 1. Let's go 1 plus 9 is 10. Plus 4 and 1 makes what?
9 plus 4. 13.
And 1 more?
14.
Yes, we carried that 1 before. 5 and 8 and 1.
5 and 8?
Yep.
13.
Plus the 1 we carried over?
14.
Yes. 1 plus 0.
What? 0?
What?
That's 1.
Right. And then 1 plus nothing is what?
1.
And where does the comma go? 1, 2, 3. Cha, cha, cha.
Behind the 4 and okay.
In between both 4s, right? But can you pronounce that number? 100 what?
In the 1,000 place.
Right, it was 114 what?
114,408.
Very good.
Can you try one more
Cameron.
time without using the word and? Don't use the word and, Cameron. You almost got it.
114,408.
Very good job,
That's
Cameron.
my buddy. Oh, Cameron. Why was 6 very nervous?
Huh?
Why was the number 6 really nervous?
I don't know.
Because it was next to 7. And 7, 8, 8. 7, 8, 9.
7, 8, 9.
7, 8, 9. You
Okay,
want to try
very
a
good job,
challenge?
Cameron.
Cameron's my man. You want to try a challenge real fast?
No.
Okay, that was a great call, though.
Good
And
job,
now it's
Cameron.
back to the next caller, and it's all you, Mr. Belton.
Next call, are you there? Hello?
Hello?
Is this Khadijah?
Yes.
Hello, Khadijah. What school do you attend?
Kettering Middle?
Kettering Middle School. You have a math question for us this evening?
Yes.
You are the very last caller of the day. We saved the best for last. How can we help you?
I'm adding integer.
You're adding integers. Okay.
And it's on a grid.
All right. What's your question?
Negative 3 plus negative 23.
Negative 3 plus negative 23.
Yes.
All right. Now, Khadijah, I'm going to give you a rule that you can use for adding integers. The 3 is negative. The 23 is also what?
Negative.
Negative. So the signs are the same. When the signs are the same, you add. So let's add 3 and 23. When we add 3 with 23, we get what?
26.
26. Now, both numbers we were adding were negative. When you add two negatives, you always get a what?
Negative.
Negative. So, negative 3 plus negative 23 is negative 26.
Okay. Can I try a challenge?
You want to try a challenge?
Yes.
You want to do the 24 challenge or the mind builders?
Mind builders.
The mind
That's
builders.
the first
Okay.
time I heard that in a while.
You're the first person today who wanted to try the mind builders, Khadijah.
She got her name in there one time already.
So your name is already going in once for your math question that we just solved. Now you want to see if you can get your name in the treasure chest for a second time by solving the mystery. It says name the mystery number. It is between 40 and 50. It is not divisible by 2. It is not divisible by 3. It is not a prime number. Khadijah, can you solve our mystery?
Is it 45?
Not 45. 45 is divisible by 3. So it's not 45.
Is it 40?
Well, 40 would be divisible by 2. So it's not 40. 50, 40 and 50 are both even numbers. Even numbers, by definition, are divisible by 2. So it's not 40. It's not 50.
But that's a good try.
And it's not 45. A very good try, Khadijah. And if you'll stay on the line or continue watching the show, we will do the honors. Mr. Herman, you want to do the honors?
Sure, I'll reach my hand in there.
Now, you can pick on one condition.
What's that?
You got to pick somebody from Gwynn Park Middle School. So
I don't do guarantees because that's also tough on me.
Let's see what we got.
It's all probability. It's all a game of chance here. We're going to see. Oh, I got one. Let's see who it is. It is Khadijah.
Khadijah.
And if you go to Domino's Pizza, you'll get some cinnamon sticks on us. And that
Very
is
good
terrific.
job,
That was the caller just called in.
She
She
just
got
called
that
in.
in. And
So
all
she
our
must have
callers.
got it. It must have worked out for her because we did the mind builder. She tried the mind builder.
She tried her best. I can feel
Worked
her
out
mind.
for us.
Well, you know, Mr. Belton, it's a pleasure working with you as always, and all those students out there in Prince George's County schools. You can always
Remember that you can always count on us.
On us.
Good job.
Absolutely.